Okay, before we move forward, I just wanted to cover this quickly. We didn't talk too much about these obliques. We mentioned that these are called oblique prisms and oblique cylinders, but we didn't talk about how to find the surface area of them, and we are not going to. It is not a requirement for this course. It's something you may cover later on. Um, but for now, we're just going to focus on finding a surface area of right prisms and right cylinders. In order to find these ones, you do need to know this length. The area of like this front side won't change when it gets slant oblique, but the area of this side will change. And it will be the slant length, which is often L, multiplied by that. So if you were curious, that's how you do it. It's very similar. When you're working with cylinders, use that slant length as well to find the lateral faces, but it's not something that you're going to need to do for this course. All right, moving forward, 11.3 is the surface area of prisms and cones. And so we're going to learn how to find the surface area, prisms and cones. So here, did I say prism? Pyramids and cones. Here are some pyramids. A pyramid is a polyhedron or a multi-faced side. Hedron means side, and poly means many. So it has many faces. In which one face, the base, the bottom, can be any polygon. So it can be a hexagon, it can be a square, and we are specifically going to deal with pyramids that have regular polygons for their bases, meaning that all of these sides are the same length. So that hexagon on the bottom is a regular hexagon. This one is a square. I don't think we're going to look at like a rectangular pyramid. And let's see. Oh, and then all of the other sides are triangles that meet up at a common vertex. Let's see. You name a pyramid by the shape of its base. So hexagonal pyramid, square pyramid. The ultimate of a pyramid is a perpendicular segment from the vertex to the base. That's how tall it is. And that's useful for finding the volume, but we're going to be more focused on the slant height, which I just mentioned. For obliques, we don't use the slant height, and it is represented by L. That's a lowercase cursive L there, if you were wondering, or script L. And we are going to use that slant height to find our surface area, because it is, of course, going to be the altitude of the side triangles. All right. It's possible that we'd have to use this right triangle to calculate what the slant height is. And let's see, regular pyramid. So all those side-facing triangles are the same. This point at the top is going to be directly above the center of the base. We're not going to look at any oblique pyramids or anything weird like that. All right. So the lateral area of the pyramid is this yellow section, the sum of the areas of the congruent triangular lateral faces. And in order to find that, you do the area formula for a triangle, which is 1/2. The side length here is the base, and our script L is the height. So 1/2 SL will give us the area of one triangle. And of course, in this case, we have 4, so we're going to multiply it by 4. But you might have 5, 6, 7, 8, 3. Depending on what shape your base is, you're going to have a different number of triangles. And then to find the surface area, you just do that. And then you add the area of the base. That here what they've done is they've also kind of maybe simplified this formula, or maybe just made it harder to understand, depending on who you are and how you think about things. They said, hey, we're really just multiplying the height of the triangle by this, and then the height by this, and then the height by this, and then the height by this. So we're multiplying the height by the perimeter. So that's what they did here. They did the height times the perimeter times a half. That works too. I kind of like this way better. But, you know, maybe they give you the perimeter and then you can save yourself some time. All right, what is the surface area of this hexagonal pyramid? So let's talk about it. And they've given us here all the information we need. So first of all, remember the surface area is going to be, well, we didn't write down a general formula for it yet, so let's do that. So the surface area equals the number of faces times 1/2 the side length times the lateral face, or the lateral distance, or the height of the triangles, plus the base area, and that'll be different depending on the shape. So in this case, our n equals 6, our s, the length of the sides, also equals 6 inches, and our L equals 9 inches. So our surface area is going to be 6 times 1/2 times 6 inches times 9 inches. Okay, and plus the area of the base. Well, the area of a hexagon is, now remember the way we think about this is that we have 6 triangles, congruent triangles, because we are guaranteed that this is a regular hexagon. We have 6 congruent triangles in the bottom. We find the area of each triangle. So the area of that, whoa, my thing just got, oh, fixed. Okay, sorry, something weird happened on the iPad. The area of the hexagon is going to be 6 of those triangles. So 6 times 1/2, and the area of a triangle, 1/2 times 6 times 3 root 3. And I'll just leave that root 3 in there so I can do a lot of this in my head. Let's see, 6 times 3 is 18, times 1/2 is 9, times 6 is 54. So we have 54 root 3. That's the area of the hexagon. So this is going to be 54 root 3. And 6 times 6 is 36, times 1/2 is 18. 18 times 9 is 162. So 162 plus 54 root 3 equals 255.53. I didn't write units. Inches squared. All right. So that's how you do it. It's really just finding the area of a bunch of triangles, figuring out how many of those triangles there are. All right, here's one for you to try. A square pyramid has base edges of 5 meters and slant height of 3 meters. What is the surface area of the pyramid? Give that one a try, and we'll have the answer for you soon, and then we'll look at cones.